Work today is broken. We're all working in too many disconnected apps, and it's killing team productivity. But for the first time, there's a platform that fixes it by combining everything you need: projects, chat, and knowledge in one place. It's all powered by the world's most complete work AI, so you can find answers from anywhere and get work done faster. Introducing ClickUp, the everything app for work.
Check this out. In just a sec, I'm going to speak with a different accent. And just between you and me, I don't really know how. But okay. First, let's change it up. So that I can fit in with the locals in Melbourne when I visit next month. Whoa, yeah, man, this is sick. Okay, let's try a different one. See if you can guess. My love is like a red rose.
Hello and welcome. My name is William and I'm super excited to bring to you this video series focused on graph theory. Graph theory is one of my absolute favorite topics in computer science. We're going to see a lot of very awesome algorithms. The whole field is very diverse and hugely applicable to real-world applications. I think everybody should be able to learn, love, and enjoy graph theory. These first few videos are going to be ramp-up videos to introduce the topics of how we store, represent, and traverse graphs on a computer. By the way, this whole video series will be taking on a computer science point of view of graph theory rather than a mathematical one. So we won't be covering proofs and so on per se. Instead, we'll be looking at algorithm implementation details and code. So what is graph theory? In essence, it is the study of properties and applications of graphs, which common folk or non-mathematical folks call networks. This is a very broad topic, and my goal with this video series is to teach you how to apply graph theory to real-world situations. Graphs can be used to represent almost any problem, which makes them so interesting because they pop up absolutely everywhere. A simple problem that can be phrased as a graph theory problem might be, given the constraints in this picture, how many different sets of clothes can I make choosing an article from each category? Of course, this could be phrased and solved using only mathematics, but the advantage to graph theory is that it allows us to visualize the problem using nodes to represent an article of clothing and edges to represent relationships between them. Another canonical example of a graph theory problem is a social network of friends. A graph representation enables us to answer interesting questions such as, how many friends does person X have? Or how many degrees of separation are there between person X and person Y?